find critical points and hence graph. Okay, so what is this thing going to look like? Well, let's think about stationary points first, and then we'll move on to points of inflection. Okay, in order to find my stationary points and determine their nature, I'm going to need the first derivative, right? Which is, someone tell me, 3x squared. Yeah, minus 6x. Okay, yeah, that's what you meant to say, right? Now, what I'm going to do here is I'm going to factorize right away. Okay, I actually probably should have done it earlier on as well because this will tell me the roots and this will tell me the stationary points. Okay, so here I can take out a factor of x squared. So that leaves me with x minus 3. So you can read the roots off that, right? What are the two roots? 0 and 3, right? Okay. Now here, when I factorize, I can take out a 3x, right? So that'll leave me with x minus 2. Does that check out? Okay. So again, off here, you can read off the stationary points, right? Yeah.
Why do we find the roots of the original equation?
I'm still going to draw this thing. I am going to draw it. Okay. So yeah, that's why. If all the question was to find critical points, I wouldn't need that. Okay. Where are the stationary points? There's one at 0, which you ought to have expected, because actually it's a double root. Right? And then there's another one at 2. Okay. Yep.
Can we format like this or like just have arrows off the side?
Okay, so at the moment I'm finding the critical points for the sake of graphing, right? So if the question was, you know, if the question had nothing to do with the graph and was find the stationary points and determine their nature, okay, you'd have to be a little more rigorous about how you set things out. But here, because I'm just doing this for the sake of this, this is enough, really, okay? When someone's marking, they're paying attention to this, okay? Yeah?
So when you graph, if say for some reason, like there's two stationary points here, but say somehow you did a question and you already knew the stationary points even though technically you shouldn't.
Mm-hmm.
Since it's just asking for a graph, if I just graphed it without showing any working.
Yes. So if it was clear on there, you know, and you actually had put in the locations of the stationary points and that kind of thing, that'd be enough. However, I mean, like most graphs, even this one, which is very simple, to know the location of the stationary points, you would have had to have had some working, right? And I know some people are really keen on having some awful, messy, scratchy piece of paper, and they do all this stuff on there, and then this is what they present. But being that you have to go through this logically anyway to work out what this looks like, at least make it look half decent. I mean, this is not beautiful, but I could present this and I wouldn't be embarrassed of it, right? So I think it's better to actually produce this, have it be legible, and have it presented along with your solution, rather than kind of riding on the fact that you ought to be okay without any working. Why not include the working? Okay, and it'll also help you when you're coming back and you're like looking at your graph and you've gotten rid of all of your rough working paper and you're like, is this right? I don't know, because I don't know what my working was, right? So working is really for you, if that makes sense. Okay, let's keep going. Second derivative. I'm going to go from this form rather than the factorized form. So that's just going to turn to 6x, and this is 6. Okay. So if I factorize again I can see, I'm not going to say points of inflection because I don't really know, but I'm going to say possible points of inflection. Right? Okay, so far so good. Now, let's think about what this thing will look like, okay? Because without doing more work, we can already get a pretty good idea of what this is doing, okay? Roots at 0 and 3. Okay, so there's the origin. And you want to be careful for your scale here now, because now that you know much more about graphs, they're going to be more stringent on having everything in the right place. Okay, so 0, 1, 2, 3. Probably useful to have this scale good anyway, because all of these are going to be critical points. Okay, so I've got 1, 2, and 3 here. Okay. Now, we were expecting a double root at 0. Okay, double root at 0, and then just one root at 3. Now this is cubic, okay, and the leading coefficient is just 1, it's positive, okay. So you know how cubics can either look like this, or they can look like this, okay. They can be overall increasing, or they can be overall decreasing. Which one is this? It's overall increasing, right? That's what that positive coefficient tells us, okay. So if I had to guess, I'd be expecting, I'll put it in another color. I'd be expecting this kind of shape, right? Coming up, double root, and then not to. Okay, so that's what I'm expecting. However, now that I know all these kinds of things, I can be more specific about these kinds of details. Okay, so for instance, this stationary point. Okay, there's one at the origin, no problems. But I'm expecting one at 2 as well. So to know more precisely where that ought to go, I ought to sub that back into my equation and find out its coordinates. Okay? So I'm going to get rid of this approximate line. What y value do you get when you pop in x equals 2? Someone got a value? Minus 4? Okay, good. So 2 minus 4. So I'm going to pop that down here. Okay? And this is well, remember from our rough sketch before, this is a minimum, right? Okay, so I'm going to go through there, and because it's a stationary point, I'm going to put a horizontal line there so that when I complete my graph, this curvature is going to look good. Alright, there's a 2. Now I've got a possible point of inflection at x equals 1. Okay, now without actually having tested, okay, because I know what this roughly looks like, I actually know it will be a point of inflection. Okay, so when I put in x equals 1, you get 1 minus 3, which is minus 2. Okay, so be careful. Since I said this was minus 4, I'm going to have to watch for my scale, right? So that's 4 units apparently. So if I come across here, that's going to have to be halfway where it changes concavity. Okay. All right. Do you think that's enough to put it together? I've also got my stationary point there, which is halfway, makes the point of inflection halfway between your stationary points. All right. Ready to give it a go? Okay, I'm going to do the in-between part first. Make sure that I'm concave down for this part and concave up for this part. Okay, so here we go. Does that look alright? And you got your point of inflection there. Okay? On the left-hand side, that's easy because it just drops off and it doesn't have to hit anything. So I'm just going to, off it goes. Okay, and there's my, my max turning point there at the origin. And I just have to finish this off and make sure I hit 3, okay? So let's try that. I almost got there. I was so close, but anyway. I've already labeled my minimum. I've already got my intercepts labeled. That's it. I'm finished, okay? Point of inflection. I should also have labeled the coordinates of my point of inflection, okay? So 1, 2, 3, all happy coordinates. Any questions on that? Sorry, say that again.
You should label your graph.
Oh yeah, thank you. Okay. Label Nazi. That's fine. Yeah, finished. Okay, happy now. We're done.